In 1944, at Willow Run, Michigan, Ford's mile-long assembly line pushed a finished B-24 Liberator off the end, roughly every 63 minutes, a scale of output that German intelligence had previously dismissed as propaganda. Within the sprawling factory, steel skeletons and aluminum panels unite as workers rivet, wire, and calibrate under glaring lights. Machinery drones ceaselessly. Each airframe, a mosaic of over 1 million components, advances toward completion with mechanical precision. In Berlin, German economic intelligence officers sifted trade statistics, captured photographs and pilot reports, struggling to reconcile their pre-war belief that Detroit mainly built automobiles with evidence that Ford was now mass-producing complex 4-engine bombers. Hermann Goering's scornful remark that Americans excel only at refrigerators and razor blades lingers in their discussions, obscuring the industrial surge unfolding overseas. When the war began, the United States Army Air Corps was modest, overshadowed by a Luftwaffe that had dominated Europe's skies. In 1940, Franklin Roosevelt called for tens of thousands of aircraft yearly, a target many dismissed as unattainable. The B-24 Liberator, first flown in 1939 by Consolidated Aircraft, emerged as a cornerstone of Allied strategic bombing, combining 4 engines, a substantial bomb load, a range on the order of 1,009 miles, and operating ceilings above 25,000 feet. Meeting that demand required production on a scale no bomber had ever seen. Henry Ford, renowned for revolutionizing car manufacturing, envisioned a bold solution. Despite his 1938 Nazi decoration, he convinced Washington that bombers could be mass-produced like automobiles in a vast new facility on Ford land at Willow Run. Ford's ambition was staggering a single plant to outpace all prior aircraft factories in heavy bomber output. Architect Albert Kahn crafted Willow Run's 3.5 million square feet, its long line curving around a county boundary to optimize space. Nearly 1,000 suppliers delivered parts, wings, fuselages, instruments into a system where standardized sections converged on a powered moving line. In 1942, early disarray hampered progress. Misaligned components and a largely novice workforce stalled production. Center wing assembly, initially a major bottleneck that had required hundreds of man-hours in earlier methods, was re-engineered with permanent jigs that slashed labor time. By 1943, refined processes and more experienced hands shifted the momentum. The line's cadence solidified, and by 1944, Willow Run was hitting its recorded peak, with heavy bombers leaving final assembly in just over an hour, the flow relentless through day and night. The heartbeat of Willow Run pulsed through its workers tens of thousands strong, who transformed Ford's vision into reality. Charles Sorensen, nicknamed Cast Iron Charlie, lived at the plant for months in the early years, adapting automobile production methods to the complexities of a heavy bomber. His insistence on standardized sections and moving lines collided with the reality that the B-24 was an unusually complex heavy bomber with intricate structures, systems, and instruments stretching from wing spars to radar sets. Edsel Ford, battling illness, managed contracts with the Army Air Forces and Consolidated Aircraft, smoothing tensions until his death in 1943, just as the plant was beginning to find its rhythm. On the factory floor, a diverse workforce, women, migrants, and first-time machinists, learned to assemble wings, wire cockpits, and test engines, defying German assumptions that such a group lacked the skill for precision aircraft. The plant's early days were chaotic. In 1942, production crawled as workers grappled with unfamiliar tasks. Misaligned fuselages and faulty wiring delayed deliveries, while the Army Air Forces pressed for heavy bomber output in the hundreds per month to sustain long-range missions over Europe and the Pacific. Sorensen's team broke the Liberator into modular sections, each built separately, and then joined on the moving line, a method untested for an aircraft of this size and complexity. Center wing assemblies, at first a crippling bottleneck, were re-engineered with permanent jigs that slashed the labor required compared with earlier methods. By 1943, experience and relentless small corrections lifted throughput steadily with Willow Run, delivering several hundred B-24 seconds in a single month and turning heavy bomber production into a routinized shift job. German intelligence, drawing on trade statistics and reports from Abwehr agents abroad, badly underestimated this transformation and assumed that such output claims were exaggerated. The Abwehr assumed that American factories, even Ford's, would stumble under the weight of mobilizing such a complex war machine. Early reports hinting that Willow Run would soon be turning out hundreds of heavy bombers each month, and approaching a bomber an hour from a single plant in Michigan, sounded implausible to analysts steeped in Hermann Göring's rhetoric about Americans being fit only for refrigerators and razor blades. Yet, as B-24 seconds joined the Great Daylight raids over Europe in ever-growing numbers, the reality of American industrial power began to pierce Berlin's skepticism. Willow Run's workers, dismissed as incapable of building a million-part bomber, were proving that such an aircraft could indeed roll off an assembly line with near-clockwork precision. Shocking those German officers who had believed that this level of production was impossible. In Berlin, German intelligence officers huddled over bombing maps and production tables, piecing together the scale of American industrial power and realizing that a single Ford plant was turning out hundreds of heavy bombers each month. The Abwehr, tasked with gauging Allied production, relied on trade statistics, neutral port observations, and occasional espionage from the United States. Their reports, filtered through assumptions of American lethargy, underestimated the output of plants like Willow Run, a B-24 Liberator with over 1 million parts, and often described as a 1.5-million-part bomber with long-range and high-altitude capability, seemed too complex for true mass production. Hermann Göring's mockery of American manufacturing, relegating it to consumer goods, shaped a mindset that dismissed claims of a bomber every 63 minutes as Allied propaganda. By 1943, the skies over Europe told a different story. American bomber formations, often hundreds strong, pounded German factories and cities with growing regularity and increasing weight. The Luftwaffe, stretched thin, struggled to counter waves of B-24 seconds and B-17 seconds, their numbers swelling beyond pre-war estimates. German analysts, reviewing raid frequencies and loss reports, calculated that United States factories were delivering thousands of heavy bombers annually. Yet the notion that a single plant could produce a million-part aircraft on an hourly rhythm remained unthinkable to many in the Reich, a blind spot rooted in misjudgment of Ford's methods. Captured Allied documents and post-raid assessments began to shift Berlin's perspective. By early 1944, data pointed to Willow Run's true output, several hundred B-24 seconds in a single month, with a peak rate of one completed every 63 minutes. The Abwehr's economic section, cross-referencing production estimates, faced the stark reality of American standardization. Albert Speer, overseeing German armaments, noted the Allies' industrial edge and admitted that Germany's factories could not match such volume. The myth of American industrial weakness, once a comforting narrative, crumbled as B-24 seconds darkened German skies, each airframe a testament to Willow Run's unyielding line, and to how badly German spies had underestimated it. By 1944, the skies above Germany roared with the thunder of Allied bombers, their formations blotting out the horizon. Thousand-plane raids, often built around long columns of B-17 seconds and B-24 seconds, hammered factories, rail hubs, and oil refineries with growing regularity and increasing weight. Each B-24, with long range of roughly 1,900 miles and operating ceilings above 25,000 feet, carried heavy bomb loads that tore into the Reich's industrial heart. German air defences, once a formidable shield, buckled under the sheer volume of aircraft. Luftwaffe pilots, increasingly outnumbered, watched their fighter strength dwindle as American factories outstripped German production. Willow Run's relentless pace with a heavy bomber completed roughly every 63 minutes at its peak fed this rising tide and turned Ford's distant plant into a silent architect of Germany's impending defeat. The Luftwaffe scrambled to intercept, but the arithmetic of war turned against them. 1,000 bomber missions, often including hundreds of B-24 seconds, overloaded radar stations and flak batteries along the approach routes. Each Liberator, a machine with over 1 million parts, and often described as a 1.5-million-part bomber, demanded precision engineering. Yet the Ford system delivered them on an hourly rhythm. German industry, under Albert Speer's direction, pushed aircraft production to nearly 40,000 planes in its peak year. but fuel shortages, pilot losses, and strains on quality control crippled their effectiveness. Speer, studying raid frequencies and loss figures, saw that Allied industry with United States plants, together producing nearly 100,000 aircraft in 1944, held an advantage that German factories could not. Erase. The efficiency of Ford's standardized line at Willow Run exposed the fragmented nature of German production, leaving their output inadequate against the growing Allied onslaught. The turning point crystallized in 1944 as relentless raids shattered German strategic optimism. Intelligence officers in Berlin, sifting through captured Allied records and comparing them with the pattern of daylight attacks, were forced to reckon with evidence pointing to Willow Run's staggering output measured in several hundred B-24 seconds from a single plant in a single month, and a peak cadence of one bomber completed every 63 minutes. The Abwehr's earlier doubts gave way to grim acceptance as the numbers matched the reality in the skies. B-24 seconds, each a lattice of over 1 million components streamed from Ford's factory, with a rhythm that mocked earlier assumptions about American limitations. Luftwaffe squadrons, bleeding pilots and aircraft at an unsustainable rate, failed to stem the flood. Hermann Goering's dismissive quip about American refrigerators and razor blades lay buried under the weight of hard arithmetic as hourly bombers from a Michigan assembly line helped reshape the course of the air war. Inside Germany, the psychological toll mounted as civilians and soldiers alike faced the unending drone of Allied formations. Cities such as Hamburg and industrial centers in the Ruhr burned under the bombs of repeated raids that included B-24 groups, their range enabling strikes deep into the Reich from English and Italian bases. Speer's reports to Hitler underlined the industrial mismatch. Even at peak output, Germany could not counter the volume, reach, and coordination of Allied air forces. Willow Run's contribution, once dismissed as implausible, now stood undeniable, its million-part bombers, often labeled 1.5-million-part machines in popular descriptions, arriving with near-clockwork regularity. The Luftwaffe, tasked with defending an overstretched empire, saw its resources eroded by the sheer frequency of operations, each wave a testament to the effectiveness of Ford's engineering gamble. The Allied strategic bombing campaign, sustained in part by Willow Run's output, shifted the war's momentum decisively. German factories battered by B-24 and B-17 strikes struggled to maintain production, while transport networks and fuel supplies crumbled under the weight of concentrated attacks on rail yards, canals, and refineries. The Reich's air defences, designed for shorter campaigns, proved ill-suited to the sustained pressure of thousand-plane operations. Ford's assembly line, producing a heavy bomber every 63 minutes at peak, helped ensure that combat losses could be replaced fast enough to maintain the pace of the air offensive. German commanders, reviewing post-raid assessments and aggregated loss tables, saw the stark truth that American industrial capacity, symbolized by Willow Run, had outmaneuvered their expectations long before ground battles crossed Germany's borders. This industrial disparity, rooted in Ford's standardized production methods, reshaped the European theater. The B-24 seconds combination of long-range heavy payload and high operating ceiling allowed United States Air Forces to strike targets across Germany, from the Ruhr to deeper industrial zones in central and southern regions. Speer, in his internal analyses and later recollections, admitted the Reich's inability to match such scale, a concession that echoed through Berlin's war rooms, even if it was not voiced publicly at the time. The Luftwaffe's decline, accelerated by bomber streams that plants like Willow Run helped sustain, left German skies increasingly open to Allied aircraft and cleared the way for ground advances. The once mocked idea of hourly bombers became a grim reality. Each B-24, a flying reminder of Germany's strategic miscalculation. The collapse of German air power under this pressure marked a pivotal shift. The Reich, facing unrelenting raids it could no longer match in the air, saw its war machine hollowed out, while a distant industrial juggernaut in Michigan quietly redefined the limits of wartime production. As 1945 dawned, the Allied air campaign, sustained in part by Willow Run's B-24 Liberators, had driven Germany's industrial system toward collapse. 1,000-plane raids built from long streams of B-17 seconds and B-24 seconds left, factories damaged, rail yards clogged, and fuel plants struck again and again. Ford's assembly line at Willow Run, which at its peak completed one heavy bomber roughly every 63 minutes, helped the United States Army Air Forces maintain unrelenting pressure on the Reich. As Germany's surrender approached, and the need for additional heavy bombers diminished planned orders for the single-tail B-24 Newtons were cancelled, and Willow Run's mile-long line slowed, then stopped. By the time production ended in 1945, Ford had built more than 6,900 complete Liberators at Willow Run, and supplied kits for almost 1,900 more, a total of over 8,600 aircraft that permanently altered the scale of wartime manufacturing. The plant's shutdown closed one intense chapter, but its methods outlived the war. Willow Run, which had begun as a troubled experiment in adapting automobile techniques to aviation, became a textbook example of high-volume production. Each Liberator was a complex machine made from hundreds of thousands of individual parts, often described in wartime and post-war accounts as a 1.5-million-part bomber. Yet Ford's organization turned that complexity into repeatable work on a moving line. Post-war analysts in the United States and abroad studied the factory's flowcharts and training schemes, tracing how defects were reduced and throughput raised, until a heavy bomber could leave final assembly on an hourly rhythm. Many German commentators examining the defeat later highlighted a consistent strategic error. They had underestimated not only American industrial potential in the abstract, but also the concrete output of plants, such as Willow Run, that were already running at a one bomber every 63 minutes cadence, while planners in Berlin still assumed far lower Allied capacity. The people of Willow Run, tens of thousands of workers drawn from cities and farms across the Midwest and the South, dispersed into civilian life, but their wartime effort remained written into the record. Women who had entered the plant as first-time riveters and electricians, and migrants who had never seen an aircraft factory before. The war built wings, wired cockpits, and prepared engines for service, defying expectations in Berlin that such a workforce could not master precision assembly on that scale. Charles Sorensen's drive to impose flow production combined with Albert Kahn's vast concrete and glass shell had turned farmland near Ypsilanti into one of the major engines of the Allied air war. The B-24 seconds role in attacks on German fuel grids, transport links, and dispersed industrial sites underlined a broader lesson that outlasted the conflict in modern war. Industrial capacity and realistic assessment of an opponent's production are themselves decisive weapons. Willow Run's legacy, symbolized by its one bomber every 63 minutes, peak, and by the million-part aircraft that rolled past its final inspection, became a warning line in post-war studies of strategy, showing how a misjudged factory and a misread enemy could tip the balance long before the last battles were fought. In 1945, as Germany's cities lay in ruins, the unrelenting output of Willow Run's B-24 Liberators stood as a testament to industrial supremacy. Each bomber, with long range on the order of 1,900 miles, and operating ceilings above 25,000 feet, had helped power 1,000-plane raids that crippled the Reich's war machine. Ford's mile-long assembly line, which at its peak completed one heavy bomber roughly every 63 minutes, supplied the United States Army Air Forces with nearly 7,000 complete B-24 seconds and kits for about 1,900 more. This torrent of complex aircraft, built from over 1 million parts, and often described in popular accounts as 1.5-million-part bombers, overwhelmed German defences and exposed the fatal flaw in Berlin's underestimation of American manufacturing. The war's outcome, shaped by factories as much as by battlefields, hinged on such industrial realities. Post-war analysis in both German and Allied studies laid bare how German intelligence had misread Ford's capacity and treated reports of an almost hourly bomber output as mere propaganda. The Abwehr, once skeptical of reports that a single plant could reach a peak cadence of roughly one bomber every 63 minutes, finally faced the accumulated evidence of Willow Run's efficiency in captured documents and raid analyses. Captured documents and raid data pointed to Ford's output charting monthly total sortie rates and the steady tempo of the Willow Run line, each aircraft emerging from a highly standardized production system that German planners had never thought possible. Albert Speer, in his later accounts, acknowledged that German industry, though driven hard, could not match the scale that American plants achieved. Hermann Göring's refrigerator jibe, once repeated as a confident dismissal of American engineering, became a symbol of hubris, mocked by the reality of Ford's relentless line, outpacing the Luftwaffe's dwindling reserves. The broader lesson of Willow Run resonated through military and industrial circles. Ford's ability to turn out million-part bombers on an hourly schedule demonstrated that wars could be decided in factories long before soldiers reached the front. Allied historians noted how the B-24 seconds range and sheer numbers, supported in part by Willow Run's flow of aircraft, enabled strategic bombing to wear down Germany ahead of ground offensives. German strategists, reflecting on their defeat, saw their failure to take early warnings about American output seriously as a turning point in the conflict. The story of Ford's plant near Ypsilanti, once dismissed in Berlin as an impossibility, became a cornerstone of wartime law, underscoring the power of industrial capacity and accurate intelligence to reshape global conflicts. In the years following 1945, Willow Run's mile-long assembly line stood silent, yet its legacy echoed through industry and military strategy. The B-24 Liberator, with long range on the order of 1,900 miles and operating ceilings above 25,000 feet, had shown that a complex heavy bomber, built from over 1 million parts, and often described in popular accounts as a 1.5-million-part aircraft, could nevertheless roll off a line at a peak rate of roughly 1 every 63 minutes. Ford's factory, once a bold experiment, became a blueprint for high-volume manufacturing, its methods studied by engineers across the globe. The United States, drawing on lessons from Willow Run and other wartime plants, reinforced its position as the leading industrial power, while former German strategists, now writing from defeat, grappled with their failure to anticipate such capacity. The plant's story underscored a lasting truth that modern wars could be decided as much in factories as on battlefields. Willow Run's techniques, driven in large part by Charles Sorensen and his production team, found new life in post-war industries. Standardized assembly, modular subassemblies, and moving lines, honed in the effort to build nearly 7,000 complete B-24s, and supply kits for about 1,900 more were adapted to automobiles, appliances, later to early jet aircraft and other complex systems. Engineers and managers noted how a workforce that included many women and migrants had mastered the million-part bomber, proving that a diverse labor force could carry out precision tasks at scale when training and process discipline were in place. Universities and research institutes analyzed the plant's output curves and quality records, pointing to the way an hourly bomber cadence at Willow Run had helped sustain the long strategic bombing campaign that wore down German industry. What the Abwehr had once treated as implausible became a case study in how disciplined process engineering could overcome complexity. Military planners reviewing the conflict came to see Willow Run as part of a strategic hinge. The United States Army Air Forces, and then the United States Air Force after 1947, wove lessons about industrial capacity and mobilization into doctrine, making clear that any future air war would depend on the ability to generate aircraft at scale, as well as to fly them in combat. German analysts writing post-war accounts acknowledged intelligence failures, particularly the tendency to dismiss early indications of American output, including reports that a single Michigan plant might reach a bomber an hour as exaggerated propaganda. The B-24's long range and heavy payload, supplied in large numbers by Willow Run and sister factories, had enabled repeated strikes deep into the Reich, a capability that helped erode German fuel stocks, transport links, and dispersed industry. Allied strategists, by contrast, credited realistic assessments of their own production base, symbolized by Ford's plant, with giving them the confidence to sustain losses and pressure until Germany's overstretched resources gave way. The human element of Willow Run's story also endured. Tens of thousands of workers had transformed raw aluminium, steel, and components into combat aircraft under intense schedule pressure. their ability to rivet wings, wire cockpits, and test engines, challenging pre-war assumptions about who could perform technical industrial work. Albert Kahn's architectural design, a sprawling factory that bent around a county line yet preserved a continuous flow, became a symbol of ambition matched by execution. The plant's peak output, one heavy bomber completed roughly every 63 minutes, stood as a monument to what coordinated planning, tooling, and training could achieve, a lesson that resonated in boardrooms and war rooms alike. Across the Atlantic, rebuilt German industries absorbed Willow Run's lessons indirectly. Engineers in cities such as Stuttgart and Munich, studying American production methods through technical exchanges and literature, adopted more standardized processes to revive their own factories. The irony was clear even to some of them, that a nation whose leaders had once scoffed at Ford's capabilities now took cues from its approach to rebuild. Military historians comparing wartime production data noted that Germany's inability to match Allied aircraft output, which in peak years approached 100,000 aircraft annually for the United States alone, had sealed its fate in the air. Willow Run's role, producing nearly 7,000 B-24s and providing kits for many more, highlighted the decisive power of industrial foresight, a principle that would shape Cold War planning as new global tensions emerged. The story of Willow Run, with its million-part bombers, often labeled 1.5-million-part machines in wartime accounts, outlived the war as a quiet case study in how misreading an opponent's industrial engine can be as costly as misreading its armies. Future conflict studies argued that planners would need to understand an adversary's factories and mobilization potential as carefully as they mapped its divisions in the field. Ford's plant near Ypsilanti, once dismissed in Berlin as an impossibility, had shown that a single facility running at an hourly bomber rate could shift the balance of a global struggle. Its legacy served as both a warning and a guide, reminding strategists that misreading an enemy's industrial engine could prove as costly as misreading its armies.